Next type of question. This is one where you're actually going to have to calculate the absolute mean deviation or the mean absolute deviation of a set of data. Here's what I'll give you. In this set of data up here, they're talking about, and this is just the problem. They're talking about the number of sit-ups that students are doing before and then after a 6-week period. So to take all this data, first thing you got to know, and this is what they give you half the time, or most of the time what they give you is they actually give you the mean number of sit-ups at the beginning of the 6-week period. So this is the beginning. The average number of sit-ups was 40 sit-ups per minute. Your job is to calculate the mean absolute deviation. All that means is what is the average distance from the mean that all of these numbers are. So that's what it's saying. It's saying take all the numbers, find the distance they are from the mean, and then average it together. So add them all up, divide by the number there are. So in both cases here, you can count the x's, and in both cases there are 20 students. So you have 20 and 20. So that means in this case, first thing I'm going to do the last thing I'm going to do at the end of solving this, I'm going to divide my solution, my sum, by 20. So here's how I'm going to add them up. What I know is the mean here is 40. So what I can do is if I write this down on paper, I can circle that 40. And now I start counting. First x I see up here, this is 30. So the question I ask is, how far is 30 away from 40? Well, that's 10 units away. So I'm writing a 10. Plus, this next one's 31. I don't have any x's here, so I'm not going to count there. Here, I have 32. And how many x's are there? I have 2 of them. So, how far is 32 from 40? That is 8 units. So I add 8, but I have to add it twice because there are 2 people that had 32 sit-ups, and both of them are included in this data. So then I keep going to the next x. The next x I see is at 35, so that would mean I add a 5 there because it's 5 units away. Here I have 2 4s because they're both 4 units away from 40. I have no 3s, I have 2 2s, so I write both 2s down. I have 2 1s right here, so I add both of those in. And now this x at 40, that is a distance of 0. So if you notice, we already counted it into our final solution when we divide. However, I could put plus 0 up here, but that's not going to affect my data. So a lot of times, to save myself the trouble, I don't put the plus 0 in there. I already counted how many people did these sit-ups. I don't have to worry about that anymore. And now it recycles. So if there was an x right here at 41, that's still a distance, an absolute value really, of 1 away from 40. But since I have nothing there, I don't add another 1. The next one I do see is a 2, so I add 2. I add a 3. I add a 4 for that 44 right there. I have 2 5s, so I add those 2 5s. I have 2 6s, and then I have 2 7s. So I add all of that together. When I added all of that together, I got a total of 90. So that means I'm going to take 90 divided by 20, which is 4.5. And that is how you calculate, that's the average distance. All of these terms are, all these x's up here, they are from 40, the mean. So you'll have a drop down in here, and it'll give you a bunch of values. What I did is I already selected the 4.5. So here, when you select, when you're clicking a little drop down, 4.5 is obviously the one that you're clicking. Okay? The next one, I'm going to go through that quickly. The next one, again, has a total number 20, but I have to go back through my word problem and see what is the mean. Well, I look at that next sentence. The mean number of sit-ups at the end of the 6-week period was 48 sit-ups per minute. So my mean over here is 48, and I'm calculating how far they are from 48. So I go back and I find 48. So 50, 49, 48 is right in here. So I have to calculate how far all these distances were. I have 2 40s, so I have 2 8s. I have a 41, so that's a 7. And I can start counting in. 6, 2 5s, a 4, 2 3s, a 2, and then 3 1s. You could put plus 1, plus 1, plus 1, or sometimes I'll just put plus 3 because I know I'm going to add those all together. Then here's 0, 1, I have a 2, I have no 3s, 2 4s. I keep going, these were 2 4s, no 5s, a 6, 2 7s, and 8. I have 2 7s over here. I ran out of room, so I have a plus 8. And then at the top up here, I have a plus 10. When I added all of these together, after I added that sum, I got a total of 96. So that total, I have to divide it by the total number of x's up here, which was 20. So 96 divided by 20 is 4.8. And that is my mean absolute deviation of the second set of data. So again, here we have another scroll down, and you're going to have to, once you drop it down, that's what you're selecting. The last question here says, from the data, what can be concluded about the number of sit-ups? Which one had more variability? Well, the question here is to compare these two statistics then. What is greater? And also, what would you expect to be greater? Would you expect someone to be doing more sit-ups at the beginning of a period where they started only focusing on sit-ups, or at the end of the period? So typically, this pretty much confirms our conclusion that 4.8 is greater than 4.5. So therefore, we want to select at the end of that period. Okay, last style of question. This style of question, this is essentially analyzing another box and whisker plot without actually having the box and whisker plot given to you. So here's what I noticed, and this time I will have to read the word problem just to be certain of what I'm talking about. Here we're talking about 26 male white-tailed deer. This wildlife biologist, had 13 deer from Big Rock and 13 deer from Red River. So there's a total of 13 in both cases. Just in case sometimes they'll ask you the question, there were more deer caught in Big Rock than Red River. Well, no, there weren't. They caught the same amount. So sometimes you will have to read that here. Now, based on what I see down here, though, I don't have that question to answer. So what I'm going to do is I'm going to eliminate certain choices first. And I want to make myself pretty much have a slam dunk of an answer here. So when I start reading, I read through all these questions, all these possible choices for this generalization. And the first one that stood out to me was letter B. The median is higher for Red River Forest than Big Rock Forest. So what that's saying is the median here, which is, we're talking about the second quartile. So do not focus on first quartile, third quartile. We're focusing between these terms right here. It's saying the median for Red River, 155, is higher than Big Rock's median of 160. Well, obviously, no. Incorrect. So right away, we've eliminated a choice, and now we've increased our odds of at least having a good shot at getting this correct. So that was the first one that stood out to me. And now I'm going to have to do a little bit of thinking on the rest of these. So now look at choice A. Red River Forest has more deer, and this is what we're talking about. We're talking about Red River Forest has more deer that weigh 160 pounds than Big Rock. So I'm coming to Red River. And I'm looking here, their median number is 155, meaning this is halfway, or 50% of the data of these 13 deer come up to 155. And here's pretty much what your box and whisker plot would look like. Because right here, this is 155 pounds. So that's the median number. Does that mean that that this 50% would be higher than Big Rock's median? Well, probably not, because Big Rock is looking at something like this, where theirs, wrote that wrong, their box and whisker plot is actually skewed up a little bit more. So, that one would actually be down a little further. And the way I know that is because I'm looking at all these different quartiles. Their median is right here at 160, so 50% of their data is actually above 160. So that's actually a false statement as well. The next one I see, part C, Big Rock Forest has more deer that weigh 155 pounds, more deer that weigh 155 pounds or less compared to Red River. So that is the exact opposite of what we're saying here. Look, I know that 50% of my data is above 160, that means I really can't make that comparison with this 155 because technically 50% of this data for Red River is below 155. So that's actually a false statement as well. The only one that makes sense is letter D, and here's that slam dunk for letter D. This is going to be 100% correct. Why? Because I'm going to calculate the interquartile ranges for both. And what that means is I'm taking quartile 3 and subtracting the lowest number, which is quartile 1. So here's how I do that. For quartile 3 for Big Rock, I'm taking 191 and subtracting 151.5. When I do so, I get an interquartile range of 39.5, and if you want units, that's pounds, because that's what we're talking about right here. Now, I do the same thing for Red River. So here was Big Rock. I took those two. For Red River, I'll do this in a different color. I have 216 minus 143. So in this case, 216 minus 143 is 73 pounds. Is that a true statement? Red River, do they have a greater interquartile range than Big Rock? Well, is 73 greater than 39.5? It is, so that's how I know this answer is actually correct. So I hope that gives you, I know the videos are a little bit longer, but I hope you can skip around with some of them. And when you have a question, hopefully one of these styles of questions helps you out a little bit more on that study island.